afternoon, everyone. And I'm Maureen Ahiataku from Ghana Meteorological Agency. And I also like to use this opportunity to thank Dr. Taylor Andrea for giving me this opportunity to make a presentation here. I'm actually a meteorologist at the Research and Applied Department, and I'm also on the Swift work package, focusing mainly on user engagement. So with this presentation, I would like to share with you some few analysis that we are doing in regards to citizen science using the media platform, the social media platform, to assess users' feedback on forecast evaluation, mainly on the weather warning that are issued towards high impact weather. This will be the outflow of my presentation. I'll give you some background, the motivation, data, results, and show you some products, satellite products, and we did some statistical analysis in regards to the skill score to this work. With the background, rainfall variability plays a major role in many socioeconomic activities within the country, and then this really affects food security, livelihood, and farming in general, as well as the early warning system, which is related to the high impact weather. But as we know, mostly in West Africa, there are a lot of challenges in data distribution, limited data distribution across most parts, including Ghana. So the citizen science is also another approach that will help to see how that can improve the gap of improving on data distribution. But the only challenge to this method I have seen is that you cannot just get maybe directly, depending on how you are going about it, you may not get the actual rainfall value, but they through the citizen science or social media platform, you could be able to assess when assuming we expect rainfall events, where those events occur, the distribution as well. So through the verification of forecast, it helps you to monitor the forecast quality, improve on the forecast quality, as well as to compare the quality of the different forecast systems that are used in terms of the models and the other weather data that are being used. So for GMET, we've identify some gap in the dissemination of forecasts to the users. Sometimes they are like people do not get the forecast in time, so we try to leverage on the social media platform to help improve the dissemination of this forecast to the users as well as the stakeholders. But for this study, I tend to focus on WhatsApp platform information to see how those feedback that comes in help to evaluate the forecast that is issued in order to improve early warning system for disaster. So the motivation for this work is to help evaluate the forecast on high impact weather using the citizen science approach, which is a WhatsApp platform basically. And then also through this study will help to users to understand and appreciate the extent to which their feedback that they share aid in the forecasts that are being prepared by meteorologists, and also help them to understand and then impact those weather warnings or storms that track through their communities, how they are being impacted, as well as communicate back to us how those information are being used. So this is the plot that you're showing. For the first one, just show you in 2050, there was a heavy rainfall that caused a lot of disaster in the country. And after that, a lot of people start generating, though people are interested in the forecast, but not so much as in this era now. So from 2017, we developed the social media platform. So with WhatsApp, it started in 2017, and so now we've seen an increase. Like in this year, we had about 3 groups that were being formed, and each of these comprises about 256 users on that platform, and it cuts across all different user platforms. So from the right table, you can see that mostly the increase in joining the platform is mainly during the major rainy season, where we have high weather impacts, especially like floods affecting a lot of people. Also, we've done some research on meteorological analysis of floods in Ghana, and we tend to understand if these storms that are tracking over the country, are they really so severe to cause this huge impact, and also to see whether most of these impacts that we are receiving, are they really through human anthropogenic activities. So we've realized that per these two systems that we've analyzed through using the Miller checklist, shows that most of the systems that are tracking were weak, but most of the flood impacts or the impact that were coming were really being induced by human activities. So for this study, we chose two weather warning events that were issued in May. And mostly in our forecast or preparation of our forecast, we use a Pullman ensemble forecast model where we combine different global and regional models to come up with this forecast together with our synopsis observations from the country. So from here, this is the first day that was on the 10th of May, the forecast that was issued in terms of the weather warning, and to the next one was on the 28th of May 2020, and the third case that was chosen was for 30th May 2020. This was the weather warning that was issued. And so in this study, the data we collected the weather warning that was issued, GMET observation data. We also augment it with the thermal data to help in the distribution. Then the feedback, users' feedback from the Let's Talk Weather platform. Our WhatsApp platform is named Let's Talk Weather. Then we also get some NWC SAP product to track how the system as well as the global imagery. First plot here shows the users' feedback. We chose out of the 7 platforms, as at the time we were collecting this data, we selected them from the 5 WhatsApp platforms. So the first platform gave us more feedback from that point, followed by the 5th and then the 4th platform. Though the 2 and the 3, though we also get some information, especially for the third case, that is the 30th May rainfall that affected the country. And also we tried to show the total observed data that were collected in terms of the station measure, the gauge measurement, both automatic and then the manual station. So we had about 115 for the 10th May, and 28th May is around 92, and then for the 30th May that was around 99 observation stations. That shows that the rainfall events actually occurred. So with the pie chart, we just to show the percentage ratio to which the stations that measure the rainfall for that day to the feedback that we collected for those events. So for the first event, about 32.4% of feedback users to the station recorded. That's also about 67.6. And then for the second day, that's 57.1 to about 42.9. And then for the third case, that's 55.9% to 41.1% of feedback, as well as the stations that we observe. One interesting thing about this feedback was it helped us to also confirm the event occurrence over areas that we do not really have the stations directly. So from the map here shows the distribution of the users' feedback in terms of their location, as well as to that of what the station is also showing in terms of the distribution. You could see more towards the points more dense here. When the platform was formed, it's invited everybody across the country to join, but we realized that most of the people are more concentrated in the city, where a lot of flood and other information also happen. But as the platform grows, we were getting people spread across the country who have joined this WhatsApp platform, and they are of different field of they cut across different sectors in that regards. So with what we have seen, so this is the rainfall distribution that was obtained from the observed station. So as we can see from the previous map here, showing the distribution right on to the north, this shows what actually happened in terms of the gauge measurement. So it's the feedback that we had in real time as the event was happening from the users conform to what the gauge measurement is also showing here. And also, we tried to look at the rapidly developing Thunderstorm Tool that was to check what actually transpired for that day, and This is also another new nowcasting tool technique that is introduced by Swift, which is GMET is also leveraging on to aid in early warning system for high impact weather. And also from this system, we could see the storms affecting most parts of the country. Just some few times were just selected to show how the event actually track over the country. We try to look at the global satellite mapping, the GS map, also to show what actually transpired for that day in terms of the satellite view. So as you can also see, for the first weather warning, the 10th, it was issued around 10 a.m. And the second one was also issued around 1:30 thereabouts, and also for the third case, it was issued around 10 a.m. to alert the public of a heavy rainfall that is going to affect the various environs that are being expected. So those names and towns or regions are being mentioned within the forecast or the warning that was issued. So after that, we decided to now try to find the scale of the forecast that was issued. So the towns that were mentioned in the forecast, we tried to see from the observation whether any rainfall that occurred over those areas. So from the contingency table was used to do this extraction, and we could see quite a good agreement in terms of when the rainfall that were expected over those areas. There were a lot of heat, and looking at the scale, accuracy was almost between 0.8 and 0.9, and with the probability of detection or the heat rate was almost 1, and with the false alarm ratio, that's quite low, so showing that the forecast that was issued or the weather warning that were issued. So in summary, I'll say users' feedback from, as we have seen, conforms with most areas that experience the rainfall event, and this approach help increase users' level of confidence and trust in the forecast that issued. And also in areas that we do not really have gauge, this information goes to help the forecaster to know how the weather warning that was issued perform, as well as the models that were used in coming up with this forecast or the weather warning, how they have fared. So in general, it helps the forecaster to know that the event occurred, the distribution, and just in the intensity, because sometimes on the platform they do share the rainfall was heavy, sometimes sharing pictures of what actually happened. So this helps also in aiding the forecast skills in real time before the main observation data is obtained, especially from the manual station. So also with this kind of approach, we have our social media, we realize that a lot of users are interest and trusting the forecast has gone in the days they normally do not really tend to appreciate the forecast accuracy. Then with the 3-day rainfall event that has been chosen for this case, we have seen like that the skill score was good for the weather warning that was issued. And also this study is going to help expand on available resources for advancing operational forecast. There had been some feedback on trying to get the users' profiles to know the gender group of the people who actually gave this feedback, their occupation, to really know maybe those involved in the disaster management, those involved in the agri sector, those into energy and all those kind of information, also to know the level of impact, or to help us get more information on the user, as well as to know how best they appreciate this information, also to help in tailor-made products that will be issued to the users. This work is also going to we will try and improve it for publication as the manuscript preparation is ongoing.
So Maureen, there seems to be some trouble with the audio. Maybe due to the video that's playing.
Pardon?
I think there was some trouble with the audio, maybe due to the video that was playing, or maybe it was just my audio. So
I think it's the video that was playing showing the hail. So I think through this social media, it has given us the information that hail have occurred. So that means more study could be investigated into those systems that track on the storm that track on those various days to identify the synoptic features or the atmospheric dynamics that actually brought about this hail to aid and the forecasters to be able to know those features to be able to forecast for hail, as well as also to know whether the models were able to predict. If it's not, then we'll try to improve on the parameterization and others, or fine-tune the models in how to improve this forecast over our region. So in general, this is what I have to share with you. Thank you.
Thank you very much, Maureen, for that interesting presentation. I would have a question right away. So it was interesting to see how you involved the community in that way. And now that you have this community built up, were you thinking about next steps, how to get them involved more closely, provide them with more specific tools, or well, there's some approaches about 3D printed low-cost weather stations, or so. Is there any project going on in that direction?
Currently, there's no project directly focusing on that, but with the Swift project, as I mentioned, that one in general is trying to help users really understand weather information within the country, how to even prepare, because sometimes people just only become more conscious to the weather warning, but the daily update they don't really track because they feel like nothing much will happen. They only happen maybe when there's a warning, and also to get more involved in trying to appreciate the work we do and how they can also request for more tailor-made products. But I think with this work will also be a stepping stone as to coming up with other projects that could help develop a better means of getting this feedback. Also, there's another work that is also going whereby we having a dissemination system that's in collaboration with the university from Uganda, Makerere University, and another university in Ghana here, RIPS, whereby we are developing a system for dissemination forecast. So in that session, we're trying to add a feedback session directly whereby they could give us that feedback directly when they access the weather information. And also we try to include audio or local forecast in local dialect for let's say farmers, and as well as the local people who may not really understand the English language, to be able to get this forecast in time, as well as also help reduce early warning disaster. That's what I'll say briefly that is ongoing now.
Okay, thank you. Very, very cool. I think this feedback loop basically benefits both, right? Your service and the people. So it's a good idea.
Yeah.
There's already in the chat. Would you like to unmute yourself, or should I read it out? I'll wait a second.
Okay, I hopefully have unmuted myself. The question was,
yes.
I visited the Ho Volta region weather forecast office a few years ago. I think it might have been 4 or 5 years ago. And the gentleman there was doing all the measurements by hand and then calling them into Accra. Have all the weather stations been automated, or at least for providing the reports back to Accra for the forecasting? If so, you guys are making great progress over there.
All right, thank you for I'll say we gradually changing most of our manual stations to automatic weather station. Yes, so I would say, and most of these data are transmitted through the GTS, which is also accessed globally. Not all of them are not fully, but most of them have been converted to automatic. And then we are getting other support from other stakeholders, let's say for the agri sector, last 2 years, they also donated about 10 extra, which is spread towards the northern part of the country for observing weather information and also to help us provide them more tailored weather products. Yeah.
And thank you also for the video of the hail in Accra. I was in a hailstorm in Ho, and I was told it was a very unusual situation to occur.
Yes, but this is particular. It's not in Accra. Some occurred in Kumasi, around Kumasi in Ashanti region, and also some in Brong, Ahafo, and that's Sunyani area towards the transition region. And I got another feedback that some also occurred in the northern parts of Volta region, that's around Pando, where we did not really get much to that. But we will try to cross-check those dates and then see what were the synoptic features or the dynamics that really led and how the severity of the storm, to know the vertical extent, the depth, and all those things, that maybe the updraft and those information, what actually led to those hails that were experienced. And this could inform future predictions of hail, which is not so frequent, but in case if it should happen again, we could be able to identify these conditions.
Well, the very fact that it's not frequent means that the impacts might be even worse on people.
Yeah, because from the picture, if you see some holding in their hands, that's quite the size. So far, we've not really gotten any information on damages so far, though.
Maureen, I think your connection's having a hiccup again.
Hello?
Yes, you're back on now, I think.
Oh, okay, sorry about that. I'm saying feedback. I'm saying that we've not really gotten any much information on the impact as if it has caused any disaster. No, but we got feedback there were hails in some parts of the country. But as to the impact, we've not really had any much information on that. But future works are in progress to really understand this phenomenon and then know the dynamics, atmospheric dynamics that brought this into play.
Okay, very cool. I would have one last question, maybe. So about the feedback concerning your weather warnings. Actually, this is maybe even more user feedback concerning your warnings than we have available. So, did you tailor anything in your warnings? Did you identify any things in which your warnings can be improved or are not matching what the community needs right now?
Okay, yeah, what we have I've identified, one is the distribution as to reaching everybody in time, and another one is the format is not so consistent. So we are trying also to go more like infographic, as well as the weather forecast. We also issue the templates we use. We're trying to now move infographic to help these users get this information in time. Another thing is also sometimes we get like untimely dissemination. Like sometimes people say it reaches them lately because sometimes through the media house, we do not control them, so they tend to disseminate at when they want, and not everybody could be maybe glued to their TV set at that moment. Though in the country, we've done some research which shows that radio is the most accessible one within the country. However, some still say they do not really get this. So that is what we're also trying to look for more IT platforms to help improve our dissemination system. So as I mentioned earlier, we are doing bringing on board the weather information dissemination system, whereby you can access both the on web-based information as well as an audio session to the forecast in local languages. And this will help in timely dissemination where everybody can access it at any point in time, and anywhere, whereby they will no more be dependent, or we will have to be relying on the media houses that until they broadcast before the users access this information. And also like leveraging on the social media platform. We use the WhatsApp group, Twitter, Telegram, YouTube, as well as Facebook to do this dissemination as well.
It sounds like a great plan to bring in all these channels. I mean, dissemination is something that everybody is struggling with. Wish you good luck with tackling the problem. And so thanks a lot for your contribution.